Hey everybody, Lars here. Thought I would jump in and do the first review video for the Unit 3 slides. I'm going to do 3 videos for this particular unit because, as you probably know by now, the slides break down easily into the 3 different components there: functions, files, and file input and output, and lastly, modularity and using modules and using the import statement. But tonight, we're going to go ahead and look at some stuff with functions. So let's begin. Alright, I'm going to grab a new file just so we have something to play around with. Let me get some comments up top. Comments. Alright, my OCD is switched. Alright, functions. Functions, people think they are harder than they have to be. Functions are actually very easily thought of as just little mini programs, because really that's all they are. The fact is, we've been using them all along. For the last 5 weeks, you've been using functions all along, but you've been using built-in functions that Python has pre-written and already loaded into memory for you. One of those, very simply, is type. I'm just going to print it. Type A. And we will see. It's going to ask me to save it. Let's save it. Where our Unit 3 code is. And I'll just call it scratch.py. And if we run it, we see class integer. So the name of the function is type. The argument or parameter that we give to the function is a, the integer, the variable a, which holds the integer 8. And the return value is this print line right here, class integer. Now, if we did it with a string, it would say string. We've used other functions as well, such as input, type itself, print itself is a function. In the past, that wasn't the case, but now it is. So now you're getting an understanding of some of the things we've been using all along. It's just we didn't explain it as a function quite as precisely as we're going to do now. Another thing that I want you to be aware of, and it's in the Python documentation right here. If you go to the Python documentation, which is right there, docs.python.org, 3, and then index.html, you'll see the documentation for Python 3, and one of the sections is the built-in functions. And you can see all the functions that are available to you. Some of them we've used. We've used input. We've used integer to cast things to integer. We've used open for our files in the second part of this particular unit. And any one of them, if you want to see what they do, you can avoid eval. Remember that. If you want to see what they do, you can just click on them and you'll be brought to the documentation on that particular function. Like keywords, it is best to avoid naming your variables after these things. We'll go look at some right now. Let's say I had a list. Close my list. And we'll make it simple. Now I just want to print sum my list, and voila. See, 20. If you give sum any iterable, anything you can iterate over, wink wink, a sequence, it will sum it up if it can. If you give it words, it will not do so. But if you give it numbers or something that can be summed up, you will get a sum, and it will sum things up for you. So in the past, to teach you loops, I've sent you off to do a loop to create your sums of your list, but now you know you don't have to do that. You can use the built-in sum function. So that's all well and good. We've been using functions all along, but the major part of this particular endeavor is to teach you how to write your own functions, how to create your own mini little programs that you can then use in your code. So do I want to keep this stuff? Nah, we'll just get rid of it. It's fairly simple. So let's say I wanted to create my own function. How would I go about doing that? Let's say I wanted to have an operation that took two numbers, multiplied them, and then gave you the, I don't know, the square of that product. So we'll call it a multi-square. Let's say I wanted to multi-square two numbers. How would we go about defining a function that did that? The first thing we're going to do is type DEF for definition or define. And we're going to define our function. Then we have to give it the name of the function, which is the first of the three parts. I'll just call this multi-square, multi-SQ. Then we have the second part, what the arguments are going to be. And I will just call these variables num1 and num2. Our colon. And then indented for, everything that we define in this function is going to be indented in, like we had to indent our loops because we're creating a block. And that block is going to be the function. So I have two variables, num1 and num2. What do I want to do? The first thing I think I'm going to do, now let me get another variable. I'll call it C. And C will equal num1 times num2. We could do this all in one line, but I'm going to avoid that. And then we're going to do the third component and return a value. And what I'm going to return is C, but I want to return the square of C. So the multi-square function is going to take two numbers. It's going to multiply them together and take that product and square it. So now, down here, I've defined my function. I have a main program down here. I'm going to print the multi-square program. And then I'm going to use it. And I'll just use it in a print statement. Well, actually, no. Let me go set a variable. I will say D equals, D is a terrible name. Let's call it answer. Equals multi-square, just like I defined it up here. And then 3 and 4. So print answer. Let me see. 12, 3 times 4 is 12. 12 squared is 144. So I believe we're going to get an answer 144. Let's find out. Yeah, that's what we got. All right. So let's go trace through this program and see what we've got here. When you run this program, the minute Python sees that def, it loads this function into memory, but it doesn't run it and it doesn't use it. It just keeps it in memory. It sets actually a variable or a handle called multi-square that points to this code, and it's ready to run when you call it. So this is just put in memory and nothing is really run yet. Then you get to here, main program, comment, so we don't run it. The first thing we do is we print multi-square program, which we see right here. Then we set a variable. We assign the value returned when we call multi-square with 3 and 4. So what happens right here? We come up here and call the function. So num1 becomes equal to 3, the first parameter matched to this variable, and this 4 becomes num2. So C is assigned the value of num1 times num2, which is 12. And then we return 12 squared. We just square it in the return. And you can do that. We could also very easily, we can get rid of this. And in parentheses say num1 times num2. And do it that way. That would work just as well, as you can see. Same thing. And we can do all of the arithmetic here in our return statement. Then the value is returned to where the function was called. And it takes that value, which is 144, and places it in the variable answer. And then we just print answer. Now, we could save ourselves more trouble here by just placing the call in the print. And we can do that right there to show you that. Okay? So in essence, that's all a function is. It's a little mini program that you can place. If you do everything in one program, you want to place it up here above your regular program because it has to already be considered and read into memory before you can use it. But once there, you can then use it in your regular program. As some of you are probably foreseeing, we're going to get to a point where this definition and this function definition is not going to be at the top of a program. It's going to be in another file because we're going to create libraries for ourselves and we're going to import those libraries, and then you'd be able to use the multi-square you built there then. Two things I want to go over really quick about functions. One is called scope, and one is a consideration of fruitful versus void functions. First, when we deal with scope, I know you've probably seen this in the Zell book and you've probably read it in other places, and everybody gets confused, and this is one of the most confusing aspects about functions, is when I pass those numbers to the function, the 3 and the 4, let's do something else here. Let's say A is equal to 3 and B is equal to 4, and then I pass A and B. Yeah, that's good. Put the B there so things don't work. B. There we go. Now, when I pass these two variables up here to the function, there's two different ways computer programs can do that, and I'm sure you've probably read or heard. There's passing by reference and there's passing by value. Passing by reference merely means that you'll take these two variables up here and point towards these variables, okay? Then there's passing by value. And passing by value means that I'm going to create two new variables and I'm going to put the values from these variables into those two new variables. So that when I'm inside the function, inside this little mini program, and I make any changes to these numbers, those numbers will not be reflected in the main program because I'm really changing these two new variables that I have running in my function. And that creates a situation that we call scope. When you call that function, you're in essence starting up a little mini program, and you're creating those new variables, and then you're running through your function. In this case, it's only the one return line, so it's not very complicated, but other functions can get bigger. We'll see some later. And then when you return the value, that program is over and it goes away. So the variables num1 and num2 no longer exist when you come back here to the main program. And we're going to show that if you try to reference them, you get errors because technically, according to Python, they no longer exist. You went and used that program, you got a result, but now it's over and it's gone. When I bring up that crazy program that I put in the slides, we're going to trace through that, and I'm going to show you some other things. Functions do have access to variables that are in here in the main program. Those are what programmers used to call global variables, where any sub-program or function that's called will have access to them. And we'll learn some more about that kind of access and even how you can limit it when we talk about object orientation in classes. But that's for the future. Right now, I just want you to understand that Python technically passes variables by value. So the 3 is going to be placed in num1 and the 4 is going to be placed in num2. Now there's a little bit of behind the scenes going on there, and we'll see that when we look at that crazy code too. But for now, as far as scope is concerned, we pass by value, and when that function is done, those variables are done, and if we try to print them, we'll blow up, and I'll show you that in a second. The second thing I want to talk to you about is fruitful functions versus void functions. You saw in the slides when I created the function that just printed the 4 lines. That's basically called a void function. It doesn't take any parameters, and it doesn't return a value. So the fact it doesn't return a value means you can just run it, it does what it does, and then it returns control to the main program. This particular function that I just wrote here is what's called a fruitful function, in that it returns a value. Now, if I ran the program as I just altered it here, that I just run it, and we will do so, you'll see it prints multi-square program, but then it doesn't do anything. Because basically all I've done is figured out what the value is, but I have not saved it in a variable. I have not printed it. I do not print it up here. It's like a missed opportunity. It was run and it said, yeah, I have the number, but I never did anything with it, so it's lost. So when you have a fruitful function, you want to do either what we did before and print it out, or you want to save it to a variable. And then when I save it to a variable, I'll have it and I'll be able to print it, and then we're back in business. As you can see, the 144 is there. So keep your eye on that. When you have functions that return values, you want to make sure that you're capturing those values, and you're either printing them out if you want to print them and have people see them, or you're saving them to variables so that you can use them at later times in your program. You will also see, as we move forward over the next few weeks, that functions can return multiple variables. And you'll want to capture multiple variables, and you can do that. We're going to see in the next program. I think I do a multiple assignment. That's easy to capture, and that's easy to do. So understand scope. We pass by value. And understand fruitful versus void. This is a fruitful function. I want to make sure I capture that variable so that I can use it later. This, I'm just going to save the Scratch program and get out of Dodge. Now, what I want to do, hope we don't have any Pirate fans out there, because they got clobbered by the Cubbies and they are out of the playoffs now. Let's see, Unit 3, code, what did I call it? I probably called it Funk Stuff. Yes, I did. All right. This, with a change or two that I did when I reviewed the code that I actually had up on the slides, is the crazy code that you saw near the end of the Unit 3 section on functions. What I'm going to do is I'm going to run this code, F5, boom, and we are going to examine exactly what it's doing to illustrate some of the things we were just talking about. All right, I ran this program. So let's trace it and see exactly what it did. The first thing I'm going to do is I'm going to set a variable equal to the string global in capitals. Okay, done. I'm going to define a function called times. It is going to take two variables, two arguments, one called A and one called B. I create a colon, boom, and I define my function. Now, this is not being run. It is just being read into memory and waiting until it is run by the main program. So I have a comment. I print this as the times function. Then I print inside IDs. When I say inside, I mean inside the function. And I run the ID function on num1 and num2. When we run the function, I'll explain what ID means. I think I've showed it to you once or twice before in these videos, but I've never really explained it. Next line, print. Can I print a global variable? And I try to print the variable before. Can I print a global after the function declaration? I print a variable called after, which is defined down here. We'll get to that. Then I print the ID of variable A, which is up here. Then I add one to A. Then I print the ID again, and we'll see what happens there. Then I take a list called myList, and I go to the third element, and I make it equal to 7. That should work, because that was my dryer. That should work because, as we know, lists are mutable, so we should be able to make that change. And then the return value is created when I multiply A times B. So I play around with some things to teach us about functions in here, but the main purpose of something called times is to times A times B, and that's what I do here. I return A times B. So when I get to the main program, let's see what I should do. It's a main program. I create a variable called after, and I give it the string value call. I create a list, a very simple list, 4 integers, 2 through 5. Then I assign num1 and num2. Here you can see it's a multiple assignment statement. The values 3 and 12. Then on the outside, not inside the function, but outside, I print the IDs of those two variables. Then I use my function print times num1, num2. Then I print the list, and then I print num1. So let's go through exactly what's happening. I set my variable. I define my function as we went through. The main program begins. I set my variable after equal to call. I set my variable myList equal to a list of 4 items. I define these two variables, num1 and num2, to 3 for num1 and 12 for num2. Okay, done. I print outside IDs, the ID for num1 and the ID for num2. So let's go up here and look at it. Outside IDs, and then you see these long numbers. These numbers are individual ID numbers. I don't know that it maps directly, but you can think of them almost as memory locations and unique identifiers for variables. Now you might be thinking to yourself, yeah, well, I already have a variable name that's unique. Why do I need that? Well, I'm going to show you some things. Sometimes when we create variables in Python, they merely point to other variables. And sometimes we get new variables, and I'm going to show you how that happens with the function thing. So when I do num1, that's the ID for num1. It ends in 304. That's good enough for now. And the ID for num2, it ends in 592. Okay, we've got that. Great. Now I want to print times function num1, num2. So the variables defined as 3 and 12 get sent to the times function. Let's go up to the times function. Times A is going to be equal to 3 because num1 was 3. B is going to be equal to 12 because num2 was 12. So I go down. This is the times function. Boom, I printed that. Okay, so far so good. Inside, I print the ID for num1 and num2 again. As you can see down here, they are the same. So I am able to access variables from the main program inside the function and show you what the IDs are for those variables. So, can I access and print a global variable that was made before my function? Yes, I can. I can access things that have been declared before the function call because I do the second thing here, print. Can I print a global after the function declaration? After. I set after equal to call here, but it's before it was called. So this function has access to the outside variables, okay? Then I print IDA, and this is where it gets a little tricky. I can see global call. I see 304. Uh-oh. It's the same as num1, okay? So you're saying to yourself, wait a minute, Lars, you told us that Python passes things by value. There should be a new variable here. Well, technically, there's only a new variable created if the program needs it. It's a little trick that Python uses in order to save space. If you've done nothing to the variable thus far, this variable will just point to num1, and we'll discuss pointers ever so briefly when we deal with data structures. Pointers are just ways of pointing at memory locations. So this variable will point to num1. So it's saying, yeah, it's still the same variable. But I then add 1 to A. And the minute I do something to the variable, you'll see the second line here, I do the same thing. I print it again. Once I alter that variable, 336, see, it's different. Python will create a new variable at that point, because at that point it has no choice. It will not change the outside variable. You have not passed by reference. You have passed by value. So what happens in here doesn't affect the variables out here. These are unique variables that are pertinent to this function code only. That's what passing by value is. Now, just to see what would happen, I went to the third element of my list and I changed it to a 7. As we all know from Unit 2, I can do that. Lists are mutable. So But I wanted to see if inside this function I had access to the list that was created out here in the main function. And we can see here, well, the first thing we do, well, yeah, let me finish out. So the third element is changed to a 7, and then I return A times B, A being 4 now because I added 1 to it, and B being 12. The return value, which is sent to this print statement, is 48, and that's why you get that 48 right there. You're not going to get 36 because I increased A by 1 in the middle of the function. So I print my list to see if my change was there, and it was. So inside of a function, I can change a mutable object that was outside in the main program. Then the last thing I do is I print num1 to show you that, yes, it is still 3. Even though we changed A to 4 here, and our 48 reflected that, num1 remains unchanged. You did not change that item inside of the function. Now, I didn't do it in there, but what if I try to print A and B? A and B were used up here in the function. I get an error because A is not defined. That function has been run, it has returned a value, and it is now out of memory and it is gone. So after that statement, the program no longer knows what A is. It does not think that A or B exist because think of it as like a little bubble universe that started up. Boom, time started up, everything got run, the value was returned, and then pop, that bubble went away. No more A, no more B. You will get an error. You cannot access those things. They don't exist anymore. They're gone. Okay? So that basically deals with scope and how you can only access certain variables inside. Now, the program that called it, the global variables there, sure, the function can see those variables. But once the function goes away, anything that was a variable particular to that function is no longer going to exist. So I will put func stuff up on Sakai. I'll put the other stuff on Sakai. If I'm not mistaken, there is one more thing that I want to do for you that I promised. I'm going to grab a new file. I'm going to do a couple of comments. What am I going to call this? I'll just say SOS. Not that we need help. Okay. Euler 6. Euler 6 was the problem where you wanted to take the square of the sum of a series of numbers and find the difference between the square of the sum and the sum of the squares. And Euler told you how to do it for 10 numbers, but they wanted the answer for 100. So we used loops to figure out what those numbers were, and then we took the difference and we got the number and everybody was happy. How could we rewrite that program using our knowledge of functions now? Let's say I wanted to just write a function that returned the sum of the squares ending at a certain number or limit. So I'm going to create a function called SOS, sum of squares. Actually, let me put the Q there so I can keep it different. Now I'm going to say for I in range 1, n plus 1, because if I put 10, it's going to be the first thing I don't want. I will just call it S equal to S plus, now this is the sum of the squares, so I want I squared. And then I will return S. I don't need the parens. I always forget. A lot of other things need parens. So I think I am there. So now I have a function where if I give it a 10 or I give it 100, it will go through that range and it will give me the sum of the squares up to that number. What's the second thing I needed? The square of the sum. I do the same thing. Only this time, for I in range 1 comma n plus 1. N is the parameter we passed into the function, remember. I am going to have s. I can use s again because it's a completely different function. This time I will say s is equal to s plus I, because I just want to get the sum of all of the numbers in the sequence. But this time I want to return its square, because that's what we want, the square of the sum. So now I've written two functions, sum of the square and square of the sum. Let's use them. I will say main program. I will print. Do I want to enter it? Why not? Let's say limit, like we used last time, equal to int input, which is a function. Enter the limit. And now I will print the difference is, and what do I want to print? I want the square of the sum, so I call my function. I'll say 10 minus the sum of the square. Same thing. And that should be 2,000 something, I forget. Let's see. Well, first I got to name it. Let's go to our code. Unit 3 code. And I will call this E6.py. And let's run it. So invalid syntax. I won't have it. For I in range. For I, hey, how about putting in the sentence? Would that help a little bit? Enter the limit. Let's say 10. Hello. Is this for the first one? Remember, things evaluate from right to left, and I had something that was undefined there being looked at. So Python said, na 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 na. 2640. That actually looks right. I think that is absolutely correct. Let's run it for 100 and see if our memories get jogged there. What am I not doing? Oh. Isn't that a nice coincidence? I took the limit and then I didn't use it. I hard-coded the 10. Let's try it again. Let's test with 10. Yes, we work. Let's do it with 100. Yay! And I think that is what we put in Euler 6 and got the check mark for, if I'm not mistaken. My OCD will not permit us to not put a space there. Why am I not getting that? Alright, let's run it again. Yes, idle. And we're in Fat City. Okay, so that's a better, more programmer kind of way of tackling that particular problem. What you want to do when you see problems that we solve with computer programming is instantly think about compartmentalizing. Okay, I need sum of squares. Let's just do a function that does that. Go and do that, and then you're done with it. Then it's a tool that you have, and you're done. What do I need next? Oh, I need the square of the sums. Okay, let me go do a function that does that. And you can see it's really only 2 lines to answer the question once we've done the setup work and created functions to do the component parts of the problem. So we took that one Euler problem, which is basically 3 different problems. Find the sum of the square is the first problem. Find the square of the sum is the second problem. And then the third problem is find the difference with the proper limit. So that to my mind, actually is a little more efficient and a little bit more elegant way of tackling Euler 6. If you remember what we did before, we just, in recipe fashion, went down the line and found our answers using loops, and then when we got to the end, we did it. This is a better way to do it because now this is a function that I can give any limit to, and it's going to give me the sum of the squares up to that limit. I can put this in a library, as we're going to see in the last part of the unit, and use it forever. I can import my tools or my special library, and anytime I call SOSQ, it's going to give me the sum of the squares. So it's useful, and it promotes code reuse as well. Okay, so that is pretty much it for functions. We are going to be using functions and doing things with functions from now until the end of the course. So I just want to get the basics drummed into your head. I know we're not doing anything incredibly complex right now. I just want you to see what you saw in the video, see what you see in the slides, and get the gist. It's just functions are just little mini programs. That's all they are. They can be very simple in that you call them and they do something and then they return to where you called them. Easy peasy lemon squeezy. Then you can have more complicated functions where you enter parameters and then use those variables in your function and then return a value back out to the main program. So we know how to create those too. We have the def to define our function, and we give the function a name. Then we give it a parameter or an argument list of variables that we're going to take in when we call it in our main program. Then, like any other program, we do our work and we use our algorithms and we use our tools, our looping, our sequences, our simple arithmetic. And then the return statement returns the value we specify, in this case, what's in variable s, to the calling program. So that's it. That's the basics of functions. People, for whatever reason, loops and functions are the two stumbling blocks when we deal with introduction to programming. They shouldn't be. Functions are made harder than they have to be by many books and many other instructors, and it's not that difficult. It's a mini program. That's all it is. After you run it, it goes away, so don't refer to any of the variables inside of it after you've run it, but after that, it's not really that big a deal, okay? Where are we? Eric and I talked about groups. A lot of people are sending me emails about groups. If you haven't done it yet and you want to do it either this morning, by tomorrow night, I'm probably going to assign people to groups if they haven't joined a group yet. So you should be getting information about the people in your groups. Then next week, Eric and I are going to start to release some information about the final project. And basically what we're going to do is we're going to create a rubric and say, this is what we want to see, but we want you to create the topic and you to pick what you want to do. Of course, it's going to be based on data science. There's going to be a big data set. There's going to be certain things we want to see. But what we're going to do is have you spend a couple weeks putting together a proposal. And then we'll review the proposals and make sure they're up to snuff. They cover everything. They're interesting ideas. And then, 9 times out of 10, we're going to say, yeah, go ahead, go do it. And then you'll have till, December to do the final project. So you can work on that on the side. Don't forget, the review of online materials is due on the 20th, which is 12 days from now. So you still have some time for that. That's not a big deal. Unit 3, 3-week process. Do functions this week. Do files next week. Do modularity the week after that. Actually, if you could, front load it a little more than that and try and set things up so you do modularity the weekend before that last week, because there's going to be 2 programming assignments, which we'll probably release over the weekend. And then you have to get ready for the quiz. But as you've seen twice already, the quiz is no great shakes. It's just a simple test of the simple knowledge. I want you to get these things down, and I want you to practice. So I'm done with this video. Over the weekend, I'll probably do a video on file I/O, and then early next week, I'll do a video on modularity and importing libraries and doing things along those lines. Somewhere else along the line, I think I'm going to do a video about your programming assignments from last week, because some of you may have caught this and some of you may not have caught this. What you got for homework in Unit 2 are two very famous programs in computer science. The CowPie program is really a problem called FizzBuzz. I didn't call it FizzBuzz because all you would do is Google FizzBuzz, and there are 300 different solutions for it on the web. I wanted to change things up. The classic program is multiples of 3 and 5 and have it print fizz or buzz, and if it's both, FizzBuzz. It's a very famous program because I can't remember the paper that discussed it, but there's a research paper that showed that 80% of newly minted CS students who have their BS degrees and go to get a job cannot do that program when asked to do it in an interview situation. So you got FizzBuzz for your first assignment. Your second assignment is near and dear to my heart because I've actually done some research on it. It was called the Rainfall Problem. And I'll explain more about it when we get to the video, but it's also a famous problem in computer science. And students in the 80s at Yale were unable to do that after their first 2 years at Yale. So I don't know what it speaks. I think it speaks to us being absolutely awful at teaching computer science. But I'll go over some of the particulars, and we'll go over how we do those programs. And also, I remember when I gave the assignment, I said I was looking for a particular elegant solution to FizzBuzz. I'll show you that too. All right? So keep going with the unit. Keep absorbing. Read the Zell. Like I said, concentrate on Chapter 6 more than anything else. Read the slides. Watch this video. If you have any questions, jump in the forum and ask. And slowly but surely, we're going to get there. We're, like I say in the slides, after this unit is complete, you're going to have the basics. You've got the basics of imperative programming for Python. Then after that, we're going to spackle. We're going to start filling in the cracks. We're going to teach you about object orientation. We're going to teach you about sorting and searching and a thing called binary search. And then we're going to teach you about exception handling and some other fun little programmer things. Okay? So you have a good night. I'll be in touch in the next couple of days. And don't forget to turn on the TV Friday night and root for the Mets, all right? Even if you're a Yankee fan. I know you guys are mourning a little bit, but it's all right. It'll be better. It'll be April in no time, all right? You guys have a good night, and I'll talk to you later. Bye-bye.